All right, today we're going to go on a journey tracing the history of the computer. We're going to go from machines that filled up entire rooms all the way to the little devices that we all carry around in our pockets. It really is the story of the incredible shrinking machine. So, let me ask you something. When you hear the word computer, what's the first thing that pops into your head? Your phone, maybe? A laptop? Well, what if I told you the very first one was something else entirely? Believe it or not, it's this, the abacus. First used way back in Mesopotamia over 4,000 years ago. And seeing this really forces you to rethink what a computer even is. I mean, at its core, it's not about screens or electricity, is it? It's any tool that's designed for calculation. And that simple idea, a tool for calculation, well, that's what leads us from these ancient beads to super intricate mechanical gears. This was humanity's first big push to try and automate all the difficult and, frankly, error-prone work of doing math. What's so cool about this period is that each one of these inventions was built to solve a real, specific problem. You had Napier's bones to make multiplication easier, then the Pascaline came along to handle addition and subtraction. And Charles Babbage's difference engine, that whole thing was designed to automatically calculate mathematical tables, which were a huge source of human error back then. But where Babbage really blew everyone's minds was with his next idea, the analytical engine. Now, this wasn't just a calculator for one specific job. It was designed to be programmable. You could give it new instructions to solve pretty much any problem. This was it. This was the conceptual birth of the modern computer, a full century before we could actually build one. Okay, so a programmable machine needs a program, right? And this is where Ada Lovelace enters the story. She saw the true, incredible potential in Babbage's machine and wrote the world's very first algorithm specifically for it. Just think about that for a second. The very first computer programmer was a woman writing code for a machine that didn't even exist yet. That's amazing. So for the next 100 years or so, that brilliant idea just sort of simmered. And then we hit the pivotal moment in our story. The shift away from slow physical gears to the lightning-fast speed of electricity. It was time to flip the switch. Now, the first electric computers, they still used these physical switches called relays. And yeah, they were faster than gears, but they were still pretty slow and made this constant loud clicking noise. Then, in 1945, ENIAC changed absolutely everything. It got rid of those clunky mechanical relays and replaced them with silent, ultra-fast electronic switches called vacuum tubes. This wasn't just a step up, it was a quantum leap in speed. But all that new speed, it came at a price, and that price was size. ENIAC weighed 30 tons. It filled a massive room. It was an absolute beast. And that right there created the central challenge for the next 70 years of computing. How do we make this powerful machine smaller? And that question kicks off the shrinking revolution. You can really look at the next 5 generations of computing as this rapid-fire race to solve the huge problems of size, heat, and cost that a machine like ENIAC introduced. So let's do a quick flyby of the key tech. The first generation was all about those giant hot vacuum tubes. The second generation introduced the absolute game changer, the transistor. The third generation figured out how to put tons of transistors onto a single integrated circuit. The fourth gave us the microprocessor, the entire computer brain on one chip. And the fifth generation, that's where we are now. It's all about making them smart and connected. But honestly, the single biggest breakthrough was that jump from the first to the second generation. The transistors solved every single problem that vacuum tubes had. They were tiny instead of huge, they were uncool instead of hot, they were reliable instead of constantly burning out, and they were cheap. This was the invention that really made miniaturization possible. The third generation was another huge leap forward. See, instead of having to manually wire all these transistors together, engineers figured out how to basically print an entire circuit onto a tiny piece of silicon. That's the integrated circuit, or what we call a chip. It meant we could pack way more power into a much smaller space, making computers even faster and, you guessed it, cheaper. And as these machines kept getting smaller and cheaper, they were finally ready to break out of the massive research labs and military bases. The fourth generation, this is the moment the incredible shrinking machine was finally ready to come home. And the key to all of it was the microprocessor. It basically took the integrated circuit idea and pushed it to its absolute limit, putting the entire computer brain, the CPU, onto a single chip. And just like that, a computer was suddenly small enough and cheap enough to fit on a desk. This one invention launched the entire personal computer revolution. And oh man, was it a revolution. Suddenly you had machines like the Apple II and the IBM PC showing up in homes and offices. We started getting all this stuff we just take for granted today, like using a mouse to click on icons on a screen, the graphical user interface, or GUI. Operating systems like Windows made these powerful machines usable by everybody, not just a handful of experts. Which brings us pretty much up to today, the 5th generation of computing. And the focus has shifted again. It's no longer just about making them smaller and faster, but about making them smarter, more connected, and totally portable. So you can see what our modern priorities are. We've got artificial intelligence built right into our apps. We're all carrying around supercomputers in our pockets. We access our data from the cloud, and we get all this incredible speed from something called parallel processing, which is really just using multiple computer brains at once to work on a problem. You know, let's just pause on that for a second. Millions of times faster. That is a scale of progress that's almost impossible to really wrap your head around. From an Abacus to an iPhone, it has to be one of the most incredible stories of human ingenuity, period. And of course, the story is far from over. We're now exploring the next frontiers. Way more advanced AI, the weird world of quantum computing, brain-inspired neural networks, and blockchain. The incredible shrinking machine isn't just getting smaller anymore, it's starting to think in entirely new ways. So if you take one thing away from all of this, let it be this. The history of computing is a story of solving problems. Vacuum tubes were too big, so we invented the transistor. Wiring was too complex, so we invented the integrated circuit. Computers were too expensive, so we invented the microprocessor. Each generation solved the problems of the last. So I guess the question for us is, what are the biggest problems we face today? And how will the next generation of computers help us solve them?